Hello everyone, and then welcome to another video. In this video we'll be treating sequences, okay? And then we've already treated rational, irrational numbers, point sets, including neighborhood and limit points and all that. So we'll continue this tutorial video from what sequences, okay? And then once again I would like to thank our subscribers, okay? In case you are a new subscriber, thank you for subscribing. All subscribers, thank you for subscribing. And then, in case you are new to this channel, I would urge you to subscribe, okay? Subscribe to the channel so that you don't miss out on any uploaded video. Because trust me, this is one of the channels you come across and then you try to lean on, okay? Because we try to give you the best, okay? Try to provide you with the needed tricks to help you with your studies, okay? Help augment your studies, okay? Right, so without further much ado, let's just dive right into this video. Right, so when we talk about sequences, okay, so we know that sequences are definite order of, or definite arrangement of numbers, definite order of arrangement of what? Numbers, okay? So it could be 1, 2, 3, 4, and all that, okay? So let's say we have what? Sequence 1, okay? We have sequence 2, okay? Sequence 3, okay? So in that order, okay? So they are just definite order of arrangement, okay? Yeah, there's just definite order of arrangement. So this sequence might have a set of numbers of even numbers, okay? And then sequence 2 could have a set of odd numbers, okay? Right, it could be set of rational numbers, set of irrational numbers, right? So provided they are what? Definite order of what? Arrangement, okay? Right, so let's say you come across a sequence and then you want to find out whether it's a finite or what? An infinite sequence, okay? So let's see how we represent finite sequences, okay? For finite sequence, okay? So we know that finite sequence have what? Ending points, okay? So this is how we represent finite sequence. So let's say we have what? 1, 3, 5, okay? 9, 11, okay? Let's say this is our sequence. This is a finite sequence because it has what? A beginning and an end and what? An end, because we do not have 3 dots over here, meaning that they are what? Infinite, okay? So when you talk about infinite, okay? Infinite sequence. Okay, when you talk about infinite sequence, those are the kind of sequences that do not end, okay? Something like 2, 4, 6, 8, okay, and then you continue like that, okay? So these are what? Infinite, they do not end. Finite sequences end, okay? They start at a point and then end at a certain point. Now let's proceed. So we have what? Different types of sequences, okay? So let's look at the various types. This is just an introductory video so that it helps you get abreast with the entire concept of what? Sequences, okay? So that we dive into the nitty-gritty portion of the entire course or subject or topic, okay? Right, so let's look at what? The types of what? Sequences, okay? So we have what? Arithmetic sequence, okay? We have the arithmetic sequence, okay? Arithmetic sequence. So for the arithmetic sequence, that's where we have what? Those form of sequences which are in what? Arithmetic form, okay? So they are usually represented with this formula, okay? That's when you want to write. You want to write the sequences in what? Arithmetic form, okay? So we have what? The sequence to be UN, okay? And then we have what? A, okay? Plus what? N minus 1, okay? And then you multiply that by what? D, okay? So I will explain what these are, okay? Now note that A, okay, is the first term, okay? Keep that in mind. A is the first term, D is what? Common difference, okay? So we have A being the first term, A being the first term, and then D being what? The common difference, okay? D being the common difference. Right. So whenever you come across what? a sequence, okay, and then you want to know whether it's what an arithmetic sequence, okay, this is how we write the what the formula, okay. Right, so let's dive right into other concepts, okay. Now when you want to find the sum of what arithmetic sequence, okay, so when you want to find out the sum of what arithmetic sequence, let me just represent it with this abbreviation, okay. So once you want to represent this or want to find the sum of what arithmetic sequence, the general formula is given by what the summation, okay, the summation of n on 2, okay, and then that's why we have 2a, okay, plus n minus 1, okay, and then you multiply that by what d. So this is how we find what this is the general form, okay. So this is just the general formula for what arithmetic sequence, and then this is what when you want to find the sum of what arithmetic sequence, okay, this is the formula you use, okay. So let me highlight that. So I'm trying to pinpoint the most salient formulas you need to know, okay. After that we just proceed. Again, this is what the general formula for what arithmetic, okay, and then this is what try to find out the sum of what arithmetic sequence. A is what the first term, and then D is what the common difference, okay. Alright, so let's proceed. So let's say you are given what an example, okay. So let's say you have given an example. Let's say okay, so now let's see if you are given what an example, okay. So you have 2, 5, 8, 11. So from here you can notice that there's what an infinite sequence because it doesn't have any ending, okay. Infinite, infinity, that's where we get the name from, okay. So we are told to find out the sum, okay. Okay, so let's say you've been given this question, okay, and you are told to find what sum of 10 terms, okay, 10 terms. So this is what the infinite sequence, and then you are told to find what the sum of 10 terms, okay. So this is the formula we'll be implementing, okay. So we have what Sn, okay, to be equal to n on 2, okay, and then we have what 2a plus n minus 1, okay, and then you have what the common difference, okay. Right, so we have that, and then you have what the common difference, okay. Right, so let's see, we are told to find out the sum of 10 terms. So these are what n, okay, these are n. So we have what Sn to be equal to, okay, so let's just represent this by the right. So we have what x10, okay. So we are finding what sum of n terms, so sum of 10 terms, okay. So S10 to be equal to what 10 on 2, okay, and then we have what 2 times a. So a is what the first term, okay. So we have what 2 plus n. N is what 10 minus 1, and then let's take the common difference, okay. So when you take the common difference of these values, okay, so common difference, so we have what 5 minus what 5 minus 2 will give us what 3. Let's check again. So we have what 8 minus 5 also give us what 3, and then the same applies to what 11 minus 3 will give us 3. So the common difference is what, right. So let's find what the sum of the 10 terms, okay. So when you compute the whole of this, so this will give us what 5, okay. So this is 5, and then we have what 4 plus what 9, okay, times 3, okay. So the whole of this will give us what 155, okay. So this is what the sum of the what first 10 terms, okay, the sum. So it means that when you sum 2, 5, 8, 11, okay, in that order. So let's say 11 in that order, okay. That's how you come up with what the sum, okay. So we have 11, 14, 17, okay, right. So when you sum up to 10, okay, to the 10th term, you end up with what 155, okay. So this is what we refer to as what the arithmetic sequence, okay. So let's look at the second what type, okay? So the second type is what? You have geometric, okay? The second type is what? Geometric sequence, okay? You have geometric sequence. So we are done with what? Arithmetic sequence. Okay, so this is what? Geometric sequence, okay? So for geometric sequence, this is the general formula we implement, okay? So we have what? The sequence equals to what? The first term, the common ratio, and then the term, okay? N minus 1, okay? Right, so, and then for finding the what? The summation of what? The sequence, we have what? The first term, okay? Multiplied by 1 minus r exponent, the n, then divided by 1 minus r. Now, this is what you have to know. For this formula, okay, this applies to only geometric sequence. So for this formula, that's the summation. Okay, so for the summation for geometric sequence, this is what you have to know. Now, for whenever you are given the question, you have to first calculate what? The common ratio, okay? So the common ratio will enable you to know the kind of what summation formula to use, okay? So first, this is the general formula, okay? This is the general formula, okay? Now, so once you calculate for the common ratio, and then the common ratio is less than 1, okay? The common ratio is less than 1. Now, this is the formula you'll be using, okay? Once the common ratio is less than 1, okay? Less than 1, you use this formula. And then once the common ratio is greater than 1, okay? Once the common ratio is greater than 1, then use this formula, okay? So let's solve a simple question so that you get to appreciate what I'm trying to say, okay? So let's say you've been given a sequence, okay? Let's say 1 on 2, 1 on 4, okay? And then 1 on what? 8, okay? And then you are told to find what? The summation of what? This sequence, okay? The summation of this sequence. First, you have to note that let's say, let me write it over here. So find the summation, okay? Or the sum, okay? Let me put it in the simplest form, okay? So find the sum of the sequence, okay? Find the sum of the sequence given n, okay, to be equal to what? 2, okay? So from here you are given what? The value of n, okay? So all you have to do is just find what? The sum of the sequence. So in order to know the kind of formula to use, okay, between these two, okay, in order to know the formula to implement, so first you need to find a common ratio by here. So from this sequence, you could notice that the common ratio is what? 1 on 2, okay? It's just simple to find. Just find a common ratio, okay? So you could do that for what? 1 on 8 and what? 1 on 4. So let's say we have what? 1 on 8 divided by what? 1 on 4. So in this simplest form, you have what? 1 on 8, okay? 1 on 8 multiplied by what? 4 on what? 1, okay? So this will give us what? 1 on 2, okay? So that's just a common ratio. So you could use the same approach for what? 1 on 4 and then what? 1 on what? 2, okay? You end up with what? 1 over 2. Now, so for the first term, you know that first term is what? 1, okay? Now, from here, we could notice that the common ratio, which is what? 1 over 2 is the same as what? 0.5, okay? And then from these two formulas, you could notice that 0.5 is not what? Greater than 1, okay? So it means that we'll be using this formula, okay? So once the common ratio is less than 1, we use this formula. Once the common ratio is greater than 1, we use this formula. But from here, you can notice that the common ratio is what? 0.5. It lies in between this range, okay? So we'll be using this formula, okay? So we have what? So we have Sn, okay, equal to what? A, and then we have 1 minus r exponent n, okay, and then divided by that by what? We divide that by what? 1 minus r. Now we are taking what? N to be 2, okay? So S2 is equal to what? The first term, which is 1, and then we have 1 minus the common ratio, which is what? 0.5, okay? And then n value to be 2, close that bracket, we divide that by what? 1 minus the common ratio, which is 0.5, okay? Right, so when you compute this, you end up with what? 1.5, okay? 1.5. Now, I hope this video was very helpful, okay? This is just an introductory video, okay? So, in the upcoming videos, we will dive right more into the various concepts, okay? We'll be talking about bounds, monotonic bounds, limits of sequences and all that, okay? Right, so again, I would urge you to subscribe so that you don't miss out on future videos, and then I'll see you in the next video. Bye bye.